Today we are going to cover the problems based upon the tactics of solving equations, and these problems are very important and taken from the various mathematical competitions worldwide in different countries, and you will find the concept will be clear, and also the one more important thing that if you are preparing for the mathematical competitions as well as you are just clearing your all the concepts from very basic level in mathematics, then such problems are very important for you. So here this is the list of some problems. You can see like this is the set of 5 important problems for the first level. You can see 1, 2, 3, 4 and 5. So we will try to discuss all the problems in the systematic manner. Also, the full briefing of solution and the stepwise discussion is also very important while we are solving or discussing the solutions of such problems. So now here we are going to start. The first problem is find the number of real solutions for x, y and z to the system, and here the 3 equations are given, and also these are in terms of 3 variables: x plus y plus z equals 3xy, x square plus y square plus z square is equal to 3xz, and x cube plus y cube plus z cube is equal to 3yz. So now here we can solve this problem as this is obvious that the zero, 0 and 0 is a solution. You can see that if we are putting the value 0, 0 and 0 for x, y, z, then you can see here the first equation is also satisfying the second equation and the third equation. In all the cases, the left hand side and the right hand sides are equal. So here we can see that 0, 0, 0 is the part of solution, and it is easy to show that if one of the x, y, z is 0, then the other two are 0 also, and below we can assume that x, y and z is not equal to 0. Just we are assuming that xyz is not equal to 0, and let a is equal to x by y, then b is equal to z by y, and the system of equations becomes like a plus 1 plus b is equal to 3ay, and here a square plus 1 plus b square is equal to 3ab, and y into a cube plus 1 plus b cube is equal to 3b. So here we got the three systems of equation. This is the first, this is second, and this is third. And now we can use 1 plus a plus b by 3a to replace y, and now here we got 1 plus a square plus b square is equal to 3ab, and 1 plus a plus b into 1 plus a cube plus b cube is equal to, this is equal to 9ab. This is 9ab, and let u is equal to a plus b, and the second assumption for the product of a and b, v is equal to ab. Then 1 plus u square minus 2v is equal to 3v, and 1 plus u into 1 plus u cube minus 3uv is equal to 9 times v. And from the first equation we can simply write the v from the first equation. Here we can write from the first equation, we have v is equal to u square plus 1 by 5, and from the second equation, also from the second equation we can write here u to the power 4 plus u cube minus 6u square plus u minus 2, and this is equal to 0. And now we can simply factorize here as u minus 2 into u cube plus 3u square plus 1 is equal to 0. So now here we can simply write the value of u as u is equal to 2, because this is the first factor. So u is equal to 2, and this will imply v is equal to 1, and here a is equal to b is equal to 1, and it means simply x is equal to y is equal to z is equal to 1. And the first solution we can write here in terms of 1 1 and 1 for x, y and z. Here also for the important result, this is the equation, and also here and this one, these are the important points for the result. So now this can be written as the value. We can see that the xyz is the first set for the solution. And now if we are just forming the function of u the function of u, and in this case we can see that this will be equal to u to the power 3 plus 3u square plus 1 has a local maximum value, has local maximum value at 5. This is 5 and the point is u is equal to -2. So this is also important point we have to mark here, that this is the local maximum value, and the local minimum value, which is 1, and the local minimum value, which is 1, can be find at u is equal to 0. So this is now here one thing is important to see, that here f of u is equal to 0 has unique real root, and here the u naught at -infinity to -2, here this will be in open interval because we cannot use the value -2 exactly, so the value must be slightly less than -2. So here we can write this in the form of open interval for -infinity to -2, and also by the Vitesse theorem, AB are the roots of the equation t square minus u naught t plus u naught square plus 1 by 5 is equal to 0, and since we can have here delta is equal to u naught square minus 4 times u naught square plus 1 by 5, and this is equal to u naught square minus 4 by 5 is greater than 0. So the equation has two distinct real roots as real solutions for a and b by exchanging a and b, and each pair AB gives the two solutions for xyz, two solutions for xyz, and this will be given by the different values of a and b. The different values of a and b will give the two solutions for xyz for different values of a, the xyz, and the different values of b, xyz. So here will be two ordered triple solutions for xyz, and here the total number of solutions are 6 for xyz in total. So here we can write there are six solutions for xyz. So this is the final conclusion, that there will be 6 solutions for x, y and z. Now in the continuation of our Second problem, here let 3 by 4, which is less than a, and a is less than 1, and we have to prove that the equation x cube into x plus 1 is equal to x plus a into 2x plus a has 4 distinct real solutions, and also we have to find these solutions. So now to solve this, we can consider the equation as a quadratic in the form a square plus 3xa plus 2x square minus x cube minus x4 is equal to 0, and the discriminant of this equation, the discriminant of this equation is 9x square, here 9x square minus 8 x square plus 4x cube plus 4x4 is equal to, here this will be the in form of complete square, x plus 2x square and whole square. We are just assuming this equation in terms of a, so here this is in quadratic form, and here this equation is quadratic in a, so the discriminant b square minus 4ac, here this is the value of discriminant b square minus 4 into 1 into c, and this is in the form of complete square. So now we can write this in the form of x plus 2x square whole square. Now here the important thing is a is equal to minus 3x, means minus b plus minus under root b square minus 4ac upon 2a, so minus 3x plus x plus 2x square by 2, and this will be equal to minus x plus x square, and here we can write for a is equal to minus 2x minus x square, and the first choice is minus x plus x square, which gives the quadratic equation as in the form x square minus x minus a is equal to 0, and here the solutions in terms of x, here x is equal to minus b plus minus under root b square minus 4ac, it means 1 plus 4a by 2, and the second choice we have for a is equal to minus 2x minus x square, gives the quadratic equation as x square plus 2x plus a is equal to 0, and here we can write x is equal to minus 1 plus minus under root 1 minus a. So here we can simply write this as in the form of inequalities to compare the values of a here. This will be like minus 1 minus a square root of 1 minus a is less than minus 1 plus a square root of 1 minus a, and this is less than 1 minus a square root of 1 plus 4a by 2, and this is less than 1 plus a square root of 1 plus 4a by 2. And now this shows that the four solutions are distinct, and here minus 1 plus a square root of 1 minus a will be less than 1 minus a square root of 1 plus 4a by 2, and this will be implies in both the sides 2 a square root of 1 minus a less than 3 minus a square root of 1 plus 4a. And now here we get the conclusion as 6 a square root of 1 plus 4a will be less than 6 plus 8a, and this will imply 3a less than 4a squared. And now we can write this in the form 3 by 4 is less than a. So now here the result is 3 by 4 is less than a, and the important points here, like the first, we have found the value of discriminant here as here, and this is the completing a square, and here the third important point is like we have transformed the equation quadratic in terms of x. So here this is the equation x square minus x minus a is equal to 0, and the second is here. So these are the remarkable points, and also the important thing is like here we have just concluded the points to compare the inequalities. So here this is the forming inequalities to compare a. So now this is the final result, and this is obviously the proper fraction, and this value is less than 1 also. So this is the final conclusion. Now this is the third problem, as given that R, S, T are all real roots of the polynomial in terms of Px is equal to x cube minus 2007x plus 2002, and we have to find the value of r minus 1 by r plus 1 plus s minus 1 by s plus t minus 1 by t plus 1. This problem is also important, and this is asked in the Ireland mathematical competition. So this is the national level competition problem, and now To solve this, first of all we have to see here that the given problem here, r minus 1 by r plus 1 plus s minus 1 by s plus 1 plus t minus 1 by t plus 1, we have to transform this by using the addition of 1 in all the terms. So r minus 1 by r plus 1 plus r plus 1 and by r plus 1. So the 1 and 1 will be cancelled out, but we have to cancel r, s and t. So now we can use the addition of 3, means 1 1 1 and minus 3 for all the terms. So here we are starting like we have here r minus 1 by r plus 1 plus s minus 1 by s plus 1 plus t minus 1 by t plus 1, and this can be written as suppose we are assuming this s, and also this can be written as r minus 1 by r plus 1 here we are using r minus 1 by r plus 1, and if we multiply this 2 times, means here we are multiplying r with 2 and just subtracting from 3, so 3 minus 2r, so this will be like here we are just using 3 minus 2r, 3 minus 2r, so this will be like r is equal to 1 by r plus 1 plus 1 by s plus 1 plus 1 by t plus 1, and one thing is important to see here, we are using s is equal to 3 minus twice of r. So here r, s, t are the roots of the polynomial px, which is given as x cube minus 2007x plus 2002. So now here we can write this r, s, t are roots of px, and this will implies r plus 1, s plus 1 and t plus 1 are the roots of qx, which is equal to px minus 1, and this will be equal to x cube minus 3x square minus 2004x plus 4008. And now by the Vitesse theorem we can write this as r is equal to s plus 1 into t plus 1 plus r plus 1 into t plus 1 plus r plus 1 into s plus 1, and this will be divided by the product of r plus 1, s plus 1 and t plus 1, and this is simply equal to minus of 2004 by minus of 4008. This is equal to 1 by 2, like here, And now we can have the value of s as 3 minus 2 times 1 by 2, and this is equal to 2. So here is the value of s as here, and this is equal to 2 finally. So here the important points to see or to note that here the operation s is equal to 3 minus 2 is done here just for the arrangement of the value, like here 1 by r plus 1 plus 1 by s plus 1 plus 1 by t plus 1, and now we have the equation here as polynomial in terms of x, and now we are using the value of the RST as roots, and just we are using here the important theorem, the Witt's theorem. This is very important and we can frequently apply in such problems. So this is the final solution. Now in the problem number 4, here a square root of x square plus 1 by 2 fourth root of x square minus 1 by 3 is equal to 0 has exactly two distinct real roots, and find the range of a, and a belongs to real number. This is important problem, and this is from China mathematical competition. And now we have to find the range of a, and this equation is given in terms of x, and this is saying that has exactly two distinct real roots. So now we can see here this is a square root of x square, so the values of x will be in the form of, you can see, the modulus, because we don't have the value of x exactly, so it may be negative or positive both. So here we have to use x in modulus, means two values. So now what we can do here, we can simply write the equation here which is given a square root of x square plus 1 by 2 fourth root of x square minus 1 by 3 is equal to 0. So now if we use the substitution, so we have here like w is equal to fourth root of x square, and this will give a w square plus 1 by 2 w minus 1 by 3 is equal to 0, and this is the first important equation we have. And now the original equation has exactly two distinct real solutions if and only if the equation here has exactly one positive solution. So when we have a is equal to 0, then w is equal to 2 by 3, and this is the unique positive solution for w. This is unique positive solution for W, and also when we are using A not equal to 0, we have only two conditions, if A is equal to 0 and if A not equal to 0. So in this case, again by the Vitesse theorem, we have the given equation here. I am just highlighting this equation by the box red color, has one positive root and one negative root if and only if A is greater than 0. So here will be one positive root and one negative root, and in both the condition A must be greater than 0. So this is the condition, this is the important condition. And the third case, if A is negative, so now when A is less than 0, then again this equation may have two equal positive roots, and in this case here is equal to 1 by 2 whole square minus 4A minus 1 by 3 is equal to 0, and here A is equal to minus 3 by 16, and the range of A will be A is greater than equal to 0 or A is equal to minus 3 by 16. So this is the final range of A, that A is greater than equal to 0, and the second alternative that A is equal to minus 3 by 16. So we have basically three conditions here. This is the third condition, this is second condition, and this is first condition. And here also one thing is important to note, that A not equal to 0 having two conditions here and here. Now this is the final problem, as problem number 5, that find the smallest natural numbers number n which satisfies the inequality 12 to the power 200 less than n to the power 300, and this is asked in Singapore mathematical competition in a secondary level contest. This problem is asked. So now we have to use the concept of exponent to solve this problem, and now we can change both the sides to have same power to compare the bases. So this is the first thing we can do here. So now we can change both the sides, like here you can see 12 to the power 200 is less than n to the power 300, and this will imply 144 here, 12 over 200. So 12 to the power 2, 144, and to the power 100, so this is 100, and less than n to the power 3 here, n to the power 3 power 100, so n to the power 3 power 100, and this will be like 144 is less than n to the power 3. So now we can then write 5 to the power 3 is less than 144, and this is less than 6 to the power 3, and this will implies that n is equal to 6 because the power is same. So we can compare the bases for n, like n is equal to 6. So one thing we have to note here, that we are just changing the both sides to let them have same power, then compare their bases. So this is the final value, and this is the remarkable point which we have to do while we are facing such problems in form of exponent. And also